In this video, we're going to do an example that practices a bit of mod and integer division. Just to remind you, mod is the idea of the remainder. So if I have 14 divided by 5, 5 goes into 14 evenly twice. That gives me 10, and what's left over is 4. So 14 mod 5 would be 4. Again, that's that remainder when you do a division. Let's open up this program called ChangeMaker. This isn't like ChangeMaker, like you're a mover and shaker of the industry or something like that. This is ChangeMaker like you're working the cash register at McDonald's and you're trying to give somebody change for some item that they bought. So just as an example, let's say that somebody bought something that was, I don't know, $4.19 and you paid with a $10 bill. How much change would you actually give them for this? It should be, I believe, $5.81. Now, that's the amount of change in total, but how would you actually give it to them? Wouldn't it be kind of a $5 bill? I think you can fit 3 quarters, no dimes, maybe 1 nickel, and 1 penny. I think is what you get from that. So we're going to have a program that basically takes in the amount that your thing cost, the amount that you paid for it, and actually spits out what is the exact change. We're going to leave the dollars just as one category. So if it's $25, it's just going to say $25. But what we're going to do is we're going to kind of figure out from this decimal point, what are the coins that you're going to be handed. So let's do this. Let's say double cost equals read double, enter the cost. Let's say double paid equals read double, enter the amount paid. And then how do I actually get how much I'm owed? Isn't it how much I've paid minus how much my thing cost? So let's do double, call it change equals paid minus cost. Now, we have one problem with this right now, and that's that I already said at the beginning of this, we're going to use a combination of mod and integer division to do what we want to do with this program. Now the problem is, this is not an integer. 5.81 is definitely a double. And you can see here I made this a double because both of these are double. When I do math between two doubles, I get a double back. But to be able to do mod doesn't actually work with doubles because what does even divisibility and remainders mean for a decimal? It doesn't really make a whole lot of sense. So I really want to convert this into an int. Right now, though, if I convert 581 into an int, it's actually going to get rid of the 0.81 entirely, and I'm just going to be left with 5, which actually kind of ruins the whole point because my change goes away. So let's do this. Instead of just converting to an int, I'm actually going to multiply this whole thing by 100. So then what I get is, after that is 581. And we're going to think of this as the total number of cents. So I'm going to do this. Let's do 100 times paid minus cost. And now we know that this number is always going to be two digits in the decimal places. So that 100 should be able to make this into an int. However, Java doesn't know that because hypothetically this read double could have any number of decimals. So what do I actually have to do to forcibly change this to an int? I need to do a typecast here. Cool. So now this should be my amount of change. And now we have to go about thinking how many dollars, how many quarters, how many dimes, how many nickels, how many pennies. And like I said, we're going to use a combination of modding and integer division to do that. Let's think about the number 581. What part of this actually represents the dollars? Hypothetically, it's everything kind of hundreds place and above. And I want to think about mathematically, how can I actually isolate the thing in the hundreds place and above? Well, let's think about what happens if I divide this number by 100. doesn't that actually just give me the number 5? Oh, I don't know why that said 581. It's because autocomplete is trying to finish this for me and it doesn't know about integer division. If I do 581 divided by 100, remember, we do integer division in this class, so it actually would be 5.81, but we get rid of the decimal, so that actually gives me 5. This is the same as if it was 2,581, that would give me 25. So this actually should give me the number of dollars. So let's do int dollars equals change divided by 100. Now that I have the dollars taken out of this, I really want to get rid of them and how much change I have left. Like if I handed you the $5 bill, how much change do I still have left to give you is kind of the 81 cents. How do I get everything left over from this? Well, that's just the remainder, isn't it? My change is now going to be 81. That's what I want it to be. And how do I get that is change equals change mod 100. Whatever is left over after I do this division with 100. You can kind of hopefully see where we're going with this. Let's do this. Int quarters equals, we said that there are 3 quarters hypothetically that fit in here. If you think about it, 3 quarters is 75 cents. I can't fit a 4th quarter. How can I actually get the idea that there's 3 quarters? Well, how many cents is a quarter? It's 25 cents. Can't I actually divide by 25? And that will actually get me 3.24 as my sticky notes actually put in for me. But we know this has to be an int, so that's going to be 3. So let's do int quarters equals change divided by 25. Then how do I get the 6 cents that are left over after that? I actually have to do mod. Change equals change mod 25. Now we know in this particular case I have 6 cents left, so I'm not going to do any dimes, but we could see a scenario where you might want to give a dime or two. So let's do this. Int dimes equals change divided by 10. Change equals change mod 10. And we're on the last one. Int nickels equals change divided by 5. In this case, if I divide this by 5, I'm going to get 1. Well, 1.2, but we know integer division, that's going to be 1. How much am I left with is actually just 1, and isn't that actually the exact amount of pennies? So let's do int pennies equals change mod 5. All right, are you ready for the world's worst print line? Let's do print line. Your change is dollars, dollars. Oops. Oh, we're so not done yet. Quarters, quarters, dimes, dimes, nickels, nickels, and we're almost there. Pennies, pennies. There we go. We finally did it. Whew. All right. And I think this should be a working ChangeMaker program. Let's go ahead and try to run this. So I'm going to compile. Oh, I compiled the whole project. Let's just compile ChangeMaker because right now the balloon program is going to get a little mad at us. And let's run ChangeMaker. And let's enter the cost. Let's do $4.19. And the amount paid is $10. And I believe it does tell me $5, 3 quarters, 0 dimes, 1 nickel, 1 penny, or 1 nickels, 1 pennies. That's fine. Okay, looks pretty good. There is actually one very small thing wrong with this program. And I'm going to go ahead and run this again. And let's do this. Let's say it cost $4.19 and I actually paid with $7. Now, there's really no reason why you'd ever do this because you would just pay with a $5 bill. Like, why'd I hand them the extra $2? But we're going to ignore that. If you actually look at this, $4.19 paid with $7 should be $2.81. And there's something actually wrong with what my change is. And if you look at it closely, you'll see that I actually lost a penny somewhere along the way. So there's something a little bit weird going on here. And let's actually think about what's happening. Remember, I actually taught you something pretty important about doubles the other day when we were kind of going through all of that math stuff. There was a little program that we looked at called Be Careful with Doubles. And in that program, we learned that doubles are inexact. And this is really important. Remember, when I store a double, it stores up to like 12-ish decimal points. And because of that, at the end of the day, there's always some sort of decimals cut off or some sort of rounding that happens at the end, which means that I can never store an exact number as a double. Now, you don't have to particularly know how the numbers are stored, but you do have to know that every now and then you're going to be slightly off. So let's think about this. What I'm reading in is $4.19 for the cost and $10 for how much I'm paid. Then I'm doing some math here. And let's try to figure out what's happening here. In this math, I should hypothetically get $281 in this case for paid minus cost. But let's actually say that those numbers are actually slightly less than what I expect to get. So instead of 2.81 for the part inside here, I actually get something like this, 2.8099999999. And this can happen again because doubles are actually inexact. So when you do math between them, you might actually be losing little bits of information or weirdly kind of gaining little extra bits of information. So this is what my number has turned into. When I multiply that by 100, it's actually 280.9999999. And what happens when I typecast this number to an int? It actually turns into just 280. So there's where my extra penny is going. Now, how do I fix this? Because it's a little annoying to not get my penny, even though pennies are basically worthless. Oftentimes, when you see something like this happening, we'll add in what's called a fudge factor. In this case, after I do this multiplication here, where I multiply by 100, I'm actually just going to add in an extra 0.5. Now, the number 0.5 doesn't really mean anything, but you want to add just enough so that it's actually making a difference. We don't necessarily know that this is exactly what's happening, but we know we're slightly off. And 0.5 should be enough to actually push me up to whatever the next number is, because your double will never be off by kind of this much. So what have I essentially done here is after I've multiplied it in by 100, I've added in here a little bit extra. So what did I do? I turned this 280.9999 to a 281.49999. And what quality does this have is that when I typecast this to an int, I cut off the decimal, but I've now added enough that I will get my extra penny. So why do you need to do this? Again, it's that idea that doubles are actually inexact. You're never getting exactly what you expect. Especially when you do math between doubles, you can have some information differences than what you would expect with the actual numbers that you put in. So what was the point of this example? Well, we were practicing a little bit of mod, a little bit of integer division, and just this reminder that sometimes doubles are not always exactly what they seem.